For more on this, I want to bring in astrophysicist Hakeem Oluseyi. He is a professor of physics and space sciences at Florida Institute of Technology and the host of How the Universe Works on the Science Channel. Thank you for joining us. So, based on what you know about the discovery, how likely is it that there is actually water on Mars?
Well, the argument that they make is really strong that they found either water that's liquid or really saturated minerals underneath this polar ice. So it's a good, strong argument, but new data is necessary to really solidify it.
Hakeem, is water an indicator that life may have existed on the planet at some point?
Well, water in and of itself is not what we call a biomarker, but all of the life that we know of on Earth, for the most part, uses water. It's carbon chemistry in the presence of water. That's almost how we define life. And so first ingredient that you need is definitely water. So if there is water, chances are there is the possibility, but there isn't yet the detection. So we don't know.
All right, so a possibility. So the kids everywhere, they're holding on to that, I think. So what significance does the depth of the water have?
Well, what's happening here is there's a polar ice cap that's made up of different layers of water. And so this lake of water, what they're calling a lake, which, that's a loose use of the term, is at the interface between the ice and the base area. And so that's pretty much it. This is something that happens on Earth at the bases of glaciers and also ice caps. You have this basal melting. So this just means that what was proposed 30 years ago as a possibility we now have strong evidence that that is in fact true.
So Hakeem, how did they actually find the body of water, and what's next to confirm that it definitely exists?
Yeah, if you look at the images that they have, they're really beautiful. So at this polar layer is layers of ice. And so what happens is they send these pulses of radar, and every time they hit a layer, there's a reflection. You get a stronger reflection. And the way you know the depth is by looking at the echo. So the longer it takes it to travel back to you, the deeper it is. So you see all these layers, but then you get down to this base layer, and in most places, you don't see much of anything. But in this 112-kilometer area, the reflection is incredibly strong. Even if you compare it to the surface reflection, it's even stronger, relatively speaking. So they knew something was up in this area, but exactly what it is required another measurement. You had to measure what's known as the dielectric permittivity. So when they did that measurement, that's the measurement that can resolve, is it rock, is it water, is it air pockets in rock? And what they find is a high value for it, which suggests that it's water. When we see that high value on Earth, typically that means that it's mineral saturated with water.
Fascinating. And finally, while we have you here, the longest lunar eclipse of the century will take place on Friday. What can you tell us about it, and why will it last so long?
Yeah, this is a good one because what's happening is several things are happening at one time. The moon is in its closest point to Earth, and when the moon passes through Earth's shadow during the lunar eclipse, Earth's shadow is not equally dark. This is what we call a central eclipse. So it's going right through that central area of Earth's shadow, and it's closer than normal. So that's what makes it much longer, and it's going to be a really good one because the moon is going to look a bit bigger also.
All right, I can't wait to see it. Hakeem Oluseyi, thank you so much. Fascinating talking about this.